Now, smoke detection, quite important. Okay, now I don't know if you've ever seen the A320 on the ground. You'll see on the left-hand side a flap about yay big, a door, a hole that big, because there is a door open, yeah, taking in air. Okay, so on the left-hand side, you'll have this avionics inlet, so it will suck in air. Okay, this fan will be blowing air into the avionics equipment. And then another extract fan just before the outlet. So on the other side, we'll also have another door, okay, which will then extract the ambient air out the other end. So on the ground, if the temperature is normal, this valve, this inlet valve, and this inlet valve will be in the open position, and air will be sucked in. Okay, it's sucked in through this blower. This blower is blowing that way. It's blowing this way, and by blowing in this way, it means it's sucking in this way. Anything before it is sucking in, and anything that after it is blowing in. Okay, so it's sucking the air in from outside, ambient air, taking it in, pushing it through the avionics equipment. So it's cooler air and it's also clean air, and then taking it and extracting it through this avionics vent outlet. Now, the situation, the smoke detector, there is a smoke detector at the extract end. So anything that's come through here will get detected for a smoke. And if there is a smoke, if there is smoke detected in the avionics system, then there is a certain procedure that happens on the ground and in the air, most importantly in the air, because on the ground you can shut everything down, but in the air, in flight, you can do a smoke, what's it called, a avionics smoke procedure, and we'll see that as the next slide coming up. But on the ground, let's stay on the ground in a minute. This is open, and depending on skin temperature, which is that's how they detect the outside temperature, these valves open or closed. So I'll give you an example. You're in Dubai. It's 40 degrees. The skin temperature is quite hot. If the skin temperature is quite hot, it means that the avionics will definitely need cooling. Okay, therefore, this valve will open to put air through here and out of here to cool the avionics under the cabin floor. Or you're in North Canada and it's December. It's minus 25 outside. So the skin of the aircraft temperature is detected that it's really, really cold. So what you do is you will close this. You won't let any cold air in because the cold air is freezing. It's absolutely freezing. In fact, you need to heat the avionics equipment up, if anything. Okay, so you don't let any air in. Okay, this fan blower is still blowing a bit of air. So what you do is you open this one a tiny little bit, okay, and force the heated avionics now to go around here like this. It can't be expelled because this is too this gap is too small. So we'll go around here, okay, and get blown in again and expelled, a little bit expelled, and the majority go around. And by doing that, we're heating up the avionics until we have a smoke, If we have a smoke, then the isolation valve will close, won't allow this recirculation of air now because the air now has smoke in it. Okay, and what it will do, it will expel all of the air overboard. Okay. Now, serious system, you're thinking, yeah, but this is on the ground. It's all right. We can open manually the outlets and everything, and it works, etc. What happens in the air? You can't have these gaping holes. This inlet and outlet they're about this big. Okay, on the aircraft, they're about 6 inches. Maybe we've got a picture of it later on. That's a gaping hole. That's going to affect the pressurization. So in the air, this valve is closed and this valve is closed to enable pressurization. Okay. Yes, it's freezing cold. It's freezing cold, but we have the air being circulated. Okay. The avionics is warming it up and it's being circulated like this perpetually. And everything's working hunky-dory. And then the avionics smoke detector, the AEVC, that's another box, a brain for the whole circuit, detects smoke. Okay, so if it detects a smoke in the cockpit, in flight, the smoke configuration, when the smoke is detected in the avionics cooling system, we'll do two things. We'll close this isolation valve. Once this isolation valve is automatically closed, not to distribute smoke everywhere at 40,000 feet, the air has nowhere to go because this valve is closed and this valve is closed. So what it will do, this valve will go into a partially open position. Okay, and you'll see a picture of it. I might have one later on to show you. The actual door, the big door, has a smaller door on it, and that little smaller door will open a little bit. And by opening a little bit, it will cause a Venturi effect, a suction effect, just like a pressurized aircraft where people get sucked out of the aircraft if there's a hole in it. So it creates a small hole, and all this air that's being then gets sucked out quickly through the little hole here, and therefore the smoke gets expelled overboard and not under the floor. Okay, so that's the way this avionics smoke detection works. On the ground, invariably in normal temperatures, the two valves are open, and you'll see that the inlet and the exhaust or outlet doors are open. And if you walk past the aircraft on the right-hand side, this will blow you. It's really hard. It's a really powerful extract fan. Okay, this one, because it's sucking in air, you can't really feel it. This one, you can really feel it. Blows you really, you put your hand in it, it will push it away. All right, on the ground, open, open. In the air, sorry, on the ground in a normal day, open, open. On the ground on a very, very cold day, okay, closed, closed. Once the aircraft takes off, in order to pressurize, these have to be closed, and they are indeed, they close. Okay, well, once the pressurization schedule is enabled, these will close and enable the aircraft to pressurize as it increases and changes altitude. And if we have avionics smoke in flight, then the isolation valve will close, the avionics the avionics outlet door will partially open and extract all the smoke overboard. Needless to say, if there is smoke detected, we have an indication. Okay, that we got avionics smoke, and we have to do the necessary actions, what the QRH would tell us. Here we have a smoke configuration here. where we have to push the button. So this, a lot of people ask me, what is this button? Gen 1 line. So Gen 1 line usually cuts the power supply from the electrical power supply. If we have an electrical fault or fire or whatever, or smoke, but it allows the fuel pumps. So if we shut down AC bus 1, for example, then we have the number 1 fuel pumps in each tank still allowing, they're being supplied electrically, despite that we've taken the power supply off them, to feed the engine. So they keep the engine going. So it's just it was an extra safety they built in when they built the aircraft. And it's just remained there. They don't use it anymore because the remaining pumps, the remaining boost pumps, have enough power to supply the engines. And the engine high pressure fuel pump itself, the geared one, has 1,000 psi. So it's got enough power to suck fuel out the wing anyway. But they put it there, and we stay with it. Okay. Now these blowers and extract fans, they are pretty important, and therefore we have 2 of them. Okay, so I'm going to go 1 picture back. There's 2 blower fans here and 2 extract fans here, 1 working at a time. Okay, so that if one fails, so in the automatic position, 1 is working, and if 1 fails, the fault will come on. Don't know which one it is, but by pressing the fault light, I will put it into override and start working the other fan. So at all times, I will be having a blowing and extraction available to get rid of any smoke that may arise, and to heat the avionics up at the same time, or to cool the avionics down. Sorry.